Hello everyone. Today let's solve the problem brain network. This one medium, right? So I'll just you can read the entire problem. They have clearly mentioned the examples with input and desired output as well. So you can read the problem statement as well. So what I'll do, I'll just summarize the problem statement for you so that it is easy to understand, right? So what the question states, we are given a network of n brains and also n brains connected by m connectors. So n brains connected by m connectors. This one is brains connected by m connectors. Also, where each connector connects two different brains. So each connector, this one connector connects two different brains. So that's what they have given in the question. What is our main goal? Our main goal is to compute the brain latency, nothing but defined as maximum distance between two brains in the network. Suppose if we are having this one, two brains, the maximum distance, we have to calculate the brain latency, nothing but maximum distance between the two brains in the network. So the distance between two brains is the minimum number of connectors that is connected to travel between them. So it can be any number of connectors connected to this one, but the minimum number of this one connectors that is needed to travel between them, that will give the this one maximum distance between the two brains. So the nervous system is valid, meaning it forms a connected graph. It has to be connected graph. So we have to find the minimum connectors that is needed to travel between the two brains. Nothing but we have to calculate the maximum distance between two brains in the network. So that's what they have given in the question. So let me delete this one. Let's discuss the approach. As usual, first step we will be going with the input reading or the input handling. So I'll not explain the input reading. So by this time you will be knowing it is same for most of the problems. So let's go to the this is nothing but the JavaScript or the Node. It belongs to Node or the JavaScript part, right? So Node, I'll just strike this one, Node or JavaScript part. So the second step will be representation of the graph. So represent the brains as and connectors as a graph where nodes are the brains. So here nodes are nothing but brains and edges are nothing but the connectors between them. So edges are nothing but connectors between them. While I explained the question, I showed you the same thing, right? Nodes are nothing but the brains and connectors are nothing but the edges are nothing but the connectors between them. During explanation of the question, I did show you the diagram, right? Same thing. So that's what here the second step, nothing but the representation, graph representation. Third step will go with the breadth first search, nothing but the BFS. So why we'll make use of BFS? We'll be using the BFS twice to find the brain latency. So that's what we have to find. We have to find the brain latency, nothing but the maximum distance traveled between the two brains, right? That is minimum number of connectors that is used to travel between the maximum path between the two brains. That is nothing but we have to calculate the main brain latency. We'll be making use of BFS, nothing but breadth first search for this. We will main thing is so we have to remember the approach that we are going is here is BFS, and also we'll start with let me explain the BFS calculation. We'll start BFS from the arbitrary brain, nothing but the node 1. Suppose this is node 1. I'm just showing this one for the example. We will start the BFS from the arbitrary brain, nothing but the node 1 here, and suppose we are having two so like this. So we'll start from node 1 BFS and we will find the farthest brain from the starting node. Suppose this is the farther brain from the starting node, and so we'll start the BFS from here. So we'll start from the BFS from here and we will find the farthest brain from the starting node, nothing but in this case, our case, it is 2. So we'll perform another BFS from the further brain found in the previous step, nothing but the distance obtained in the second BFS will give the brain this one latency, nothing but we will be applying BFS again over here, which will give the distance that is obtained in the which will give the distance that will give the brain latency. So that's what that's how we will get the brain latency. So third step will be optimization, nothing but here the fourth step will be optimization. We'll be using an efficient BFS approach to handle the large inputs within the problem constraints, nothing but the fourth step will go with here as we will output here, nothing but we will output the result. So we have to display, right? We'll get the output here, we'll get the maximum distance, nothing but the brain latency over here. So we have to display here, as we are making use of the JavaScript or the node, we'll be making use of the console log and we will print the output, right? So that's what we'll be doing in the fourth step. So I hope this is clear. This is the approach that we will be going. Main thing is just remember we are going with the BFS and how we calculated the brain latency here, which I showed this one. I hope this step is clear. Let me delete this one and let's start writing the code so that it will be very easy to understand. So initially we'll input file. We'll go with the input handling, nothing but we are importing the file system module to read the input from stdin. Let me write here fs equals require of this one fs. So the second one is we will read the input. We'll split by new line. Why? Because we have to read the every input, right? Every line, nothing but the different input from every line. And also we will trim the white spaces, which is not necessary. So I'll just give or else I'll just take input here. This will be easier to understand. fs dot read file sync. This one initially we'll start with 0 and we'll set the encoding to UTF-8. So this is one thing. Next we will be trimming all white spaces. Trimming all white spaces here, and let's make use of the split. So n, this is one thing. So yeah, this is fine. Next, let's pass the first line of the input to get the number of brains and connectors. We have to get the number of brains and connectors. So for that purpose, we'll be passing the first line of the input. I'll not assign individual this one variable to this one. And let's make use of the destructuring operator instead. I'll just go with m, n. Fun to parse, I'll just we have made use of the input, right? So input of first line. First line is nothing but it is indicated by 0 within the array. And to read the distinct numbers or the characters that we are that we have in the input, so it has to have the space, right? So let's leave space over here, and we are making use of number type. So this will be number. You can make use of the big int as well here. So I'll just go with the number. So if we are dealing with the large numbers or large inputs, we can go with the big int. So in this case, I'll just go with the number. If there is difference in the output, so the last two digits or the last three digits are wrong, we are getting the output wrong for the big numbers. For the larger numbers, then let's go with the big int, right? So here, this is fine. Next, let's initialize the adjacency list to represent the graph, nothing but one based index, right? So this will be, as usual, it will be adj equals array dot from. Here I'll just consider the length. Length, I'll just give n plus 1 here. This is fine. Let's initialize this one to empty square bracket. So after initializing the adjacency list to the to represent the graph, that is nothing but one based index, we will we'll declare the visited array to keep track of the visited nodes during the BFS. Nothing but we'll perform the BFS. We have to keep track of the visited nodes during the BFS as well, right? So that's why we will be making use of the visited array. So I can just initialize visited. This one I can just give new here I'll be making use of typed arrays. So this will be memory efficient. So that is the reason I'll be making use of typed arrays. I'll just make use of uint 8-bit array. So of size n plus 1. The reason I have made use of the this one typed array here is because it will be memory efficient. So let's build the graph by reading all the connectors, nothing but the edges, right, from the input. So we have initialized everything. So the next step is to go with the iteration. So let's start the iteration. In simple term, it will be let I equals 1, I less than or equal to m. Let's increment this one. So here let's make use of the, I'll just make use of the destructuring operator. Here I'll just give input of iterated value of the input or split. We have to read the distinct numbers. So I'm just leaving the space over here. This will be of type number, right? We are getting the, you have to get the maximum number. So it will be of the type number, maximum number of maximum distance. So this will be of type number. So map of number. So we will add B as a neighbor of A and vice versa, and A as a neighbor of B, since the graph is undirected. So this will be ADJ doesn't A, but I'll just make use of the push of B. So here this will be adjacent B dot push of A, this one. So this is fine. After this, we will perform the BFS, or we'll write the function to perform BFS, and we will return the farthest node and the distance to it. So in this step, as I've said, we'll be making use of the BFS approach, right? So this is main thing. Just focus on this. So just give me a second. Let's start function BFS, or let me make use of this one. It's BFS equals, let me consider start as the parameter. So I'll just give here a Q and initialize this one to start. So this is nothing but I'm making use of the Q for BFS, that is starting from the start node. So you can tell in that way. So next, let's make use of the distance array to store the distance from start node to each node. Nothing but we are initializing this one to infinity. So distance array, I'll just write dist. So I'll just consider array of size n plus 1, and I'll initialize this one. I'll just fill this one with infinity. So this is fun. So next we will calculate the distance to start node, to the start node, that is 0 initially. So I'll just give dist of start. Let me set this one to 0. So here let's set the variables to let's set the variables to keep track of the farthest node and the maximum distance. So this will be farthest node and max distance, right? Farthest node, I have not initialized this one. We are initializing this one, right? Farthest node, this is equal to start, also maximum distance, this is equal to 0. This is fine. Next, after the initialization, as usual, we'll be going with the iteration or the loop. So I'll be making use of the while loop here. So because we should be having the length of the queue, right? So if only we'll be having the length of the queue, we can go, we can move further. So for this purpose, I'll just be making use of while loop. Nothing but while we don't have any nodes to explore. So I'll just make use of while over here. While length of the queue, then we will dequeue the front node. Nothing but we will remove the front node. Dequeuing, right? I can write in this way. Let u equals, for dequeuing, the first node we have to remove from the first this one, right? First element. Then I can just make use of the shift, right? For this one, I'll just give shift. We are nothing but we are dequeuing the front node. So after this, we will explore all the neighbors of the current node u. So all the neighbors. So let's go with the for loop again. For let v of adjacent u. So this one. Here, if the neighbor has not been visited yet, nothing but if the distance is still infinity, then we will update the distance of neighbor to v, right? So this is condition. So I'll just make use of the if. Here, the distance of v, this is equal to infinity, then we can update the distance of neighbor v. So dist of v, this one I can just give dist of u plus 1. So after this, we will check if the new distance is the maximum that is found, that we have found so far. Nothing but the new distance that we have found is the maximum. So again, I can just make use of the if, as this is condition. This one will be distance of v. If it is greater than the maximum distance, nothing but we will set the maximum distance to distance of v. I hope this is clear. Next, we will update the farthest node as well. So we can just give farthest node. We can give this one to v. We can initialize this one to v. So after this one, we have to enqueue. Nothing but add the neighbor v for the further exploration. We have to keep on exploring, right? For exploring further, we have to add the neighbor v. Nothing but we have to enqueue the neighbor v. So for adding or enqueuing, I'll just make use of the push. So here queue dot push of v. This is one thing. Next, after this, we will return the farthest node and its distance from the start node. So I'll just give a return over here. In this case, farthest node and maximum distance, right? And we can write in this way, farthest node and maximum distance. So we can write in this way. So this is fine. After doing this, we have come to the end of the code. Nothing but first, this is nothing but the first BFS from an arbitrary node. We choose node 1. We are choosing node 1 over here. We have performed BFS, and this is nothing but the first BFS. We'll be choosing the first BFS from an arbitrary node. Arbitrary node is nothing but the node 1. So we have to start the BFS, right? So that is the reason. For first BFS, second BFS I'll be considering. And we will be performing the, while explaining the approach, I said, we will be, while we perform the second BFS, through the second BFS, we will be getting the maximum, this one. Yeah, maximum distance, right? So first BFS, I can write this one as first BFS equals BFS of 1. This is one thing. And I'll also second BFS equals BFS of, will be first BFS dot farthest node, and also let me make use of the console log, or we'll just log the second BFS along with the maximum distance. So I'll just give console log of the second BFS and also along with the maximum distance. So this is it. So I'll just check with the input that they have given in the question. So the desired output is 2, right? So I'll just come here. Let me paste it over here and hit the run button. So what happened? Type. So we are getting cannot read properties of undefined reading push. So somewhere we have done a wrong thing here. Line number 14. This one, right? I have missed something over here. Let me just check. Give me a second. So what mistakes I have done here is, in the line number 9, you can see here, I have misspelled visited. So this has to be visited, visited, right? So this is one thing. And I'll just come to line number 21. Here, I have initialized dist, right? So I have initialized the array here and of size n+1, and we have filled this one with infinity. So this has to be dist of start, not, I have just misspelled here again, DIS. These were the two typos. Let me hit the run button. So again, we are getting cannot read properties of undefined, right? Let's see what is wrong further. So here, what is my main mistake is, here you can see I have given let m comma n within the destructuring operator, m comma n. This has to be n comma m. Why this has to be n comma m? Because n is the number of nodes and m is the number of edges, right? So this has to be n comma m, not m comma n. So now this has to work correctly. So let me check once again. Just give me a second. I hope this works. Let me hit the run. So yeah, now we are getting the output 2, right? So I'll just come here. We are getting the correct output, right? So let's check with the last input. This has to give the output 3. I hope this gives the correct output. So yeah, we are getting 2 and 3. So this is correct. So just give me a second. So let me copy this one and let me paste it over here. It will be, let me click on submit code. Let me choose B and let me paste the code over here and hit the submit. So let's wait for some time. So here this is showing in queue. Actually, I don't know why this is not showing this one accepted from it is taking very long time actually. Actually, we have checked this one here, right? So we are getting the correct input. This is correct solution. Actually, I have checked this one earlier as well. So this solution works absolutely correct. And so yeah, this is it. Thanks for watching, guys.